Okay, Championship Academy, 5th grade. Welcome back from spring break. I hope everyone is well, in good health. I hope everyone has had a fun spring break amidst the quarantine and the issues we've been having. I hope everyone has been safe. I want to start the year off, sorry, not the year. I want to start the session off slow, and I want to do a recap of what we've been doing before. I'm going to go in more details in Class Dojo as to like everything that we're doing, but we only have one more section on math to do, and then we are done for the year. So what I really want to concentrate on is IXL and also going on iReady, and then picking the areas that we have like the most challenges with, and then really ramp up on repetition of those areas that we have challenges with. So we're going to be doing IXL, I'm going to be doing these online courses, and what we're going to do is figure out what areas of improvement we need to do. So without any more delays, what we're doing is a recap of triangles. Now, there are 3 ways to define a triangle. It can either be through the angles. There are 6 ways to define them. They're broken up into angles and the sides, the line segments. So the angles that we're going to start with the angles first. Now with triangles, there are 3 ways we can define the angles. The first way, I apologize, it's going to be, the wording is going to be backwards because it's recording, not much I can do about that. But the first way to define the angles of a triangle is acute. A acute angle triangle, ACUTE, acute angle triangle, is a triangle that has an angle less than 90 degrees. All 3 sides of the triangle are less than 90 degrees. So if you're looking for an acute angle triangle, all 3 angles are less than 90 degrees. That's an acute angle triangle. Now, let's say I wanted to determine what is less than 90 degrees, or like how to find out what that acute triangle is. What I like to do is I use my reference, which is a right angle triangle. So a right angle triangle, this is a 90-degree angle right here. Now, you see something very specific about the right angle triangle. You would either have the number 90 in it, or you'll see this little box. I don't know if you should be able to see that. This little box right here that indicates that it's 90 degrees. So you're either going to see that box, or you're going to see the wording or the number 90 degrees. Now, a trick I like to do, if I'm ever curious if a triangle angle is 90 degrees, I like to bring the corner of a box or the corner of like the page, and I measure it, because that's always going to be what that 90-degree angle is, the corner right there. So if this angle is less than 90, what I like to do as well, I like to put an imaginary line. So let's say I put an imaginary line right here. So that would be my 90-degree angle. If it's less than 90, I know that it's acute. So this would be an acute angle. This is a right angle. And then the third way to define angles of a triangle is obtuse. Now, obtuse angle triangle is a triangle that is greater than 90 degrees, but less than 180 degrees, which is a straight line. So between 91 degrees and 179, that's obtuse. So I did the same thing. I did my little imaginary line. I made my 90-degree right there. And if it's greater than, I know that it's obtuse. If it's less than, I know that it's acute. So those are the 3 ways we can define a triangle with the angles. Now, there are 3 more ways we can define a triangle with this is going to be with the line segments, or the distance of the actual lines of the triangle. Now, the 3 ways we can define that are scalene triangles. Now, a scalene triangle, SCALENE, scalene triangle, is a triangle where all the lengths are different. So each line segment here has a different length. That's how we can define a scalene triangle, because all lengths are different. Now, let's say it's not drawn to scale like this and we're not 100% sure which line length is correct. What will happen is you'll notice that it'll have these little lines on triangles to show that they are the same length. So let's say two lengths are the same. We would call that an isosceles triangle. An isosceles triangle is a triangle where two lengths of the triangle are the same. So we see those two little lines there. So even though we don't have the measurement, because we see those definitive lines, this signifies that those two are the exact same. So the scalene, we notice that they don't have any small dashes on it. So we know all of these line segments are different. Isosceles, we see two of them. So we know that these two are the same, but this third one is not the same. So this is an isosceles triangle where two of the lengths are the same. And then the last one is a equilateral triangle where all three lengths are the same. And you can see defined by those three dashes right there. So you will either see those dashes, or what you would see is the actual length. So it would say 5 meters, 5 meters, 5 meters, for example. We know that would be an equilateral triangle. Or if it was 5 meters, and then 9 meters, then we know that these two are both 5, so they're the same, and then the bottom one is 9, which is not the same. So that would be an isosceles triangle. And then they're all three equilateral. If it was 5 meters, 4 meters, and then 3 meters, I guess I did that wrong, 5, 4, 3, then we know that it's scalene because none of them are the same. So we can define it by acute angle triangle, where all three angles are the same. All three angles are smaller than 90 degrees, An acute angle, all three angles are smaller than 90 degrees. We can define it by a right angle triangle, where it has one 90-degree angle or one right angle in the triangle. Or we can define the triangle by obtuse, where it has one angle that's greater than 90 degrees, which is an obtuse angle triangle. Acute, all angles are less than 90. Right angle, it has one 90-degree angle. Obtuse, it has one angle that's greater than 90 degrees as angles. And then scalene triangle, all three sides are of different length. Isosceles triangle, two sides are the same length. And then equilateral triangle, all three sides are the same length, or all line segments are the same. Now, definitely feel free to pause at any time. This is a recap, so I might be going a little bit fast. Definitely pause and then write your notes, and yeah, to keep up. Now, I have another paper to give. I want to go over what I just said, and I want to make sure we can practice it. Make sure we understand what we're doing. All right, so with these 10 triangles on the board for now, I want us to only define by angles. So I only want to know if it's an acute triangle, which is a triangle that has 3 angles that are less than 90. If it's a right angle triangle, meaning it has one angle that's 90 degrees, or if it's an obtuse triangle, which has one angle that's greater than 90 degrees and less than 180. Now, I'm gonna give you time to, I want you to pause the video, and I'm gonna write all 10 down. We're only going by acute, obtuse, and right angle. So pause the video, get your answers, and then we'll come back. Okay, so we've all paused the video, we did our work, and I highly recommend pausing and doing the work. That repetition is really going to help. So, number one, if I were to say number one is an acute triangle, would I be right or incorrect? I would be incorrect. Why would I be incorrect? Because right here, this is less than 90 degrees. That's an acute. That's good. Right here is less than 90. That's also good. But when we go right here, we see that little box. We know that that's 90 degrees. Like acute angle has all three less than 90, but this is 90, making that a right angle triangle. Now, number two, if I were to say that is an acute triangle, would I be correct? Yes, I would be correct. Number two is an acute triangle because all three angles are less than 90 degrees. That is an acute triangle. Number three, if I were to say number three is obtuse, I say number three is an obtuse angle triangle. Would I be correct? No, I would be incorrect. Again, you can always measure the angles. What I like to do is put those 8 lines there and measure it. If you're not 100%, if it's less than 90, it's acute. If it's greater, it's obtuse. So this is less than 90 because it's over here. Less than 90, acute, acute, right angle. What about number four? What if I were to say number four is a right angle triangle? Would I be correct? No, I would be incorrect. Number four is also a acute angle triangle. All right, what about number five? If I say number five is an obtuse triangle, would I be correct? Yes, I would be correct. Because again, remember, let's put that fate line there, that 90 degree, and measure it. This angle right here, it goes, I hope I'm not locking, it goes greater than 90 degrees. Right here, because it's greater than 90 degrees, so that would be a obtuse angle triangle. Number six, if I were to say it is a acute, would I be correct? Yes, I would be. Number seven, if I say number seven is a obtuse triangle, would I be correct? No, I would not be correct. You see that little box there? We know that this is 90 degrees or a right angle. So this is a right angle triangle or a 90 degrees triangle. Number eight. If I were to say number eight is acute, would I be correct? No, I actually would be incorrect. Number eight is an obtuse triangle. So right here is acute, so that's good. Right here is acute. But if we line up here and we make our 90 degree, we may have to go that, we can see that this angle right here is actually greater. I don't know if you can see that, but the angle right there is actually greater than 90 degrees. Number eight is obtuse. Number nine, if I were to say is a right angle triangle, would I be correct? Yes, I would. And then finally, number 10, if I were to say number 10 is an obtuse angle triangle, would I be correct? Yes, I would be correct. Number 10 is a obtuse angle triangle. So really hope that you pause to read them out. But that is it for angles. If you go on IXL, it's going to have a little program just to repeat what I'm doing, just to make sure you guys understand the 6 ways to define a triangle. You can either, it's acute, which means that all angles are less than 90 degrees. Obtuse, where it has one angle that's greater than 90 degrees. Or right angle triangle, where it has one 90 degree angle. And we have scalene triangles, which means all sides are of different length. We have scalene isosceles triangles, which 2 sides are of the same length. And then equilateral triangle, where all 3 sides are the same length. So what I want you to do now is we're going to answer if they are Answer, I'm sorry, by line segment. So I want you to tell me if it's scalene, isosceles, or equilateral. So again, I'm going to pause the video, write out 1 to 10. You're going to tell me if it's scalene, isosceles, or right angle. And I'm scalene, isosceles, or equilateral. I apologize. And pause. We are back. All right. I really hope you guys paused the video, went through, did your work. All right. Number 1. I want to know if that is a scalene, isosceles, or equilateral. Triangle number 1, if I were to say that is a equilateral triangle, would I be correct? I would be incorrect. Equilateral triangle is all 3 of the same lengths. It usually is defined by those lines to signify that. So it doesn't have the length, it doesn't signify with these to say that they're the same length. So number 1 would be a scalene triangle. Number 2, if I were to say number 2 is an isosceles triangle, would I be correct? No. Well, technically, it is an isosceles and equilateral triangle because isosceles has 2, so it has 2, but equilateral means that all 3 are the same. So this would be better defined as an equilateral triangle. It is isosceles because it has 2 of the same, but when you see 3, it is looking for equilateral. Number 3. If I were to say number 3 is an equilateral triangle, would that be correct? No, I would be wrong. It looks very close to equilateral, but they're either going to have the measurements on them or they're going to have these little lines to signify that they're the same length. So we don't see that here. So we know that this is not equilateral. We know that it's not isosceles because it doesn't have any lines. It doesn't have 2 equal. So it would be a scalene. Number 4, if I were to say that's a scalene, would I be correct? I will be incorrect. We see that it has 2 line segments that are the same, so we know that's an isosceles triangle. Number 5, that would be a scalene because it doesn't signify any of the lengths are the same. Number 6, I think that would be a scalene. Would I be correct? I would not be correct. Number 6 is a equilateral triangle. You can see clearly defined by those angles. And then if you said number 7, 8, 9, and 10 were scalene, you are correct. Number 7, 8, 9, and 10 are all scalene triangles. Now I want to talk about the angles. Now, every triangle, when you add up the angles, it always equal to 180 degrees. So I can't even write it because it's going to be backwards, but all triangles equal 180 degrees. All triangles equal 180 degrees. So this triangle right here, this is 90 degrees. If I say this is 60 degrees, up here, I know that this is 90, this is 60. All triangles equal 180. So we know that this has to be 30 because that would be 90 plus 60 plus 30. Sorry. I'll put that more tape. I need to get a dry erase board. I ordered one on Amazon. I'm just waiting for it to be delivered. We're gonna have to make do with this in the meantime. But yeah. So all triangles, when you add up all the angles, they always equal to 180 degrees. So 90 plus 60, if we add that together, well, we do 9, they both end with 0, so 9 plus 6, which is going to be 15. You add back the 0, which is going to be 150. When you get 150, you add 30. 150 plus 30 equals 180. All triangles, they always add up to 180 degrees. So let's say this triangle right here. Let's say we had 60 degrees here. 60 and 100 degrees. So it's not drawn to scale, but if we have 100 degrees on one, and then we have 60 degrees, what's that going to be? 100 plus 60, that's going to give us 160 plus something, let's say A, is equal to 180. So remember, we always know that all triangles always add up to 180 degrees. So if we have 100 degrees on one angle, and then we have 60 on the other, when we add those together, we get 160. And we know that all triangles, when you add it together, they have to equal to 180. So if I have 160, I don't know what that third angle is, but I know it equals, or has to reach 180. What we can do is say, how can we move, how much more do we need to add to get from 160 to 180? So I know if I had 10 more to 160, I'm at 170. And if I had another 10, I'll be at 180. So I know that this missing angle here, or A, we know that this would have to be 20. 100 plus 60 is 160. We need to get up to 180, so plus 20 more. Boom, we get 180. Let's say, I need to write it probably a little bigger. Let's say I have 40 degrees on one angle, and then I have, let's do 80 degrees plus something, let's do Q is equal to, we know it's a triangle, so it has to equal to 180. So I know what 40 plus 80 plus something is going to give us 180. Now 40 plus 80 is 120. We're at 120 and we need to make it to 180. We know that 120. What I like to do, there are two ways to do it. One way is we're adding with numbers base 10. So all we need to do is we're at 120 right here plus something equals 180. What we can do, because we know that we're adding base 10, we can just take the zeros away and then just add our way up to 180. So if I take the zero away from 120, I'm at 12. So 12, 13, 14, 15, 16, 17, 18. So I know that I need 6 to get up to 18, and then I add back the zeros. So that's going to be, if I add back the 0 to 6, that's going to be 60. So I know I need 120 plus 60 is going to give us 180. Now, let's do another one. I believe in rules of 3. Let's say this triangle right here. We know that this is 90 degrees because we see that little angle there, so that's 90. Let's say I spoke to a little birdie and they told me that this was, let's go 70 degrees. So we know that this is 90, this is 70, but that little birdie flew away. He wouldn't tell me what the third degree is. But I know that it has to equal to 180. All triangles, they always equal up to 180. So I know 70, 90, but I don't know C. 70 plus 90. 70 plus 90, what would that be? Add back, I like to take away the zeros. 7 plus 9 is going to be 16. You just add back the zeros, so 160. So We know 160 plus C is equal to 180. Now, again, I don't know what C is, but I know that we have to make it up to 180. So how much more do I need to move from $160 to 180? I know that if I add 10 more than that, we're in base 10s, I add 10 to that, I'll be at 170. If I add another 10, I would be at 180. So if I were to add 20 to that, I would get 180. So we know that C is 20. Now, that's one way of adding it in base 10. Another way of adding, which I like or I prefer, because sometimes you may not be adding in base 10, is I like if we do this. So let me get my other sheet that I have. And then, actually, you know what? I'll just flip this around. I'll flip this one around and then I'll go to the questions I have written down. Okay, so let's say we have a triangle here, and we know that this is 60, this is 60, but this is x. We don't know what that is. So we have 60 plus 60 plus x, and we know that all triangles equal 180. So 60 plus 60 is 120. Oops. 120, that's terrible. 120 plus x equals 180. Now, 120 plus x equals 180. What we can do is we need x by itself. So what we can do is we can take away the 120. Now, if we take away 120, what's another word for take away? It means subtract or minus. If we take away the 120 on the left, we have to do the same thing on the other side. So that's going to be 180 minus 120. We leave the x by itself. So we know that x, or the missing angle, is going to be 180 minus 120. So x is going to be, what's 180 minus 120? Take away the zeros. It's going to be 60. So we know that x, or the missing angle right here, because it has 180, is 60. Now, let's try another one. Let's say the angles aren't as solid as that. Let's say we have 82 degrees, 82 and 48. And we don't know what C is. We know that this is 82 degrees, this is 48 degrees, and this, we don't know what that is. So we know that we have 82 degrees plus 48 degrees plus C is equal to, it's always going to equal 180. What's 82 plus 48? 82 plus 48. I want to give you a minute, but I don't have that much time. 8 plus 2 is going to give us 0 at the end. Remainder 1. 4 plus 8 is 12 plus 1. That's 130, or 13 plus C is giving us 180. Now, we have a numerator, we have a number, and a letter. What we need to do is we need to get the letter by itself. So what we do is we take away that number. We have C on the side by itself, we just take it away. Now, whenever we take away on one side, we have to do the same thing on the other. That's going to be 180 minus 130. What was that going to give us? If you pause the video and do it, it's going to give us, so we now know that C is equal to 50. Rule of threes, let's do a third one. Let's say we have one more triangle here. Let's do 97 and 35. 97 degrees, 35 degrees, and Q. We don't know what Q is. What we do know is all angles equal, all triangles equal 180 degrees. That's going to be 97 plus 35 plus Q is equal to 180 degrees. So now 97 plus 35, what would that be? 7 plus 5, that's going to be 12. 9 plus 3 plus 1, it's going to be 13. So we know that 132 plus Q is equal to 180 degrees. So again, you have a number and a letter. So what we need to do is we need to let that letter be on the side by itself. So what we need to do is we take away the 132. So that's going to be Q is equal to 180. Whatever you do on one side, you have to do the other. If we took away 132, we have to take away 132 on the other side. What's 180 minus 32? That's going to be 48. So we now know that Q is 48. So it's going to take a little repetition, but what I want to do is I want to get these 5 questions on the board, and then, I'm sorry, 4, and then I'll have you guys three, and then I'll say them because they might be maybe too big. And yeah, if you're not fully understanding, or feel free to rewind and then go over what I just said. And you probably can't even see the numbers. I'm gonna write them a lot bigger so you can see them. So this is 60, 90, and then A. This is 70, 30, then C. This is 120, 40, and then D. This is 60, 60, and then C. So we know that should be big enough. 60, 90, and then A. 70, 30, and then C. 120, 40, and then D. 60, 60, and then C. So we know 2 out of the 3 angles for all of them. And we know that all angles equal 180 of a triangle. So whatever this is, you can figure this out because we know it has to equal to 180. So I'll pause it, give you guys a minute. Well, I won't pause it. I hope that you pause it, give yourself a minute, really, break it down, figure it out. And all right, we're back. You guys did what you're supposed to do. You paused the video. So we have 60 plus 90. That's going to give us 150. We know that. Let's put the plus signs here. Plus signs here. 60 plus 90 is 150. 150 plus A, we can't add that. So we make sure that the letter is by itself. You take the 150 away, whatever you take away on one side, take away on the other. That's going to be 180 minus 150. A is going to be 30 for number 2. 70 plus 30 is 100. 100 plus C, you can't add a number and a letter. You got to separate the letter by itself. You take away the 100. When you drag down, whenever you take away on one side, you got to do it on the other. 180 minus 100 is going to give us 80. Number 3, 120 plus 40. When you add those together, we're going to get 160. 160 plus D, you can't, you got to take it away from one side. When you take away from one side, you got to do the same thing on the other. 180 minus 160. D is going to give you 20. And then number 4, 60 plus 60 plus something equals 180. 60 plus 60 is 120. 120 plus C, you can't. You got to take the 120 away. Whenever you take away on one side, you have to do on the other. 180 minus 120 is going to give you 60. Okay, so if you have any questions, we have the IXL. I assigned it to everyone. Go through it. I'm going to go through and see like who needs help, who has mastered it. Definitely feel free to contact me. I'm going to go through everything with your parents, like to reach out to me. But that's it for the first day. I feel like we've done a lot. Go through IXL, definitely go through the lessons, pause it, make sure you understand it, and it's going to make it a lot easier for you if you get that repetition before you actually go on IXL. So thank you for your time, and you guys have been great. Take care.